Hello students, welcome to Saralsa classes and this is Dr. Sarkar over here. We were discussing the protection and deprotection of alcohols using acetal strategy. We would like to extend on that topic a little bit more. So here we are going to present a technique that uses the methoxy methyl, that is CH3OCH2, also called MOM, that means methoxymethyl, and tetrahydropyranyl, that is THP groups, also are called ether groups. For example, the hydroxyl group was protected to give the ether of MOM. Okay. But actually, they are examples of acetals that are cleaved via acid hydrolysis. Okay. Now, when we are joining a MOM into a alcohol, we are basically using a very reactive chloromethyl methyl ether. Okay, and a THP group is used, and the THP group is actually formed by the reaction of an alcohol with the dihydropyran. So out here in the example, what we will say, suppose this is the again isopropanol we are using, and that is being treated with the ClCH2OCH3, which is known as the chloromethyl methyl ether, obviously in presence of tosic acid, and that will lead to the formation of this type of an ether, also can be represented as OMOM, or in a separate strategy we may use the DHP in presence of catalytic amounts of the acid, and that will lead to the formation of this unit, which has the THP attached to it. Now, if we were to think of deprotecting these alcohols, then basically we will be considering the use of aqueous acid, that is acidified water, and that will be removing the groups, that is that one or that one, and regenerate the alcohol for us. Okay. Now that is all that we had to discuss regarding the protection of alcohols. Now we would like to stretch the idea to protection of carboxylic acids. Now, interestingly, carboxylic acids have a acidic proton, and that can interfere with any type of basic species, including amines. So, carboxylic acids are usually protected using esters, mostly a methyl ester. So, we will say carboxylic acids are protected using methyl esters. What is the structure of a methyl ester? It will be simply RCO2CH3. And there are a variety of ways by which this methyl ester can be prepared. So it can be what? Let's see. It can be basically a acid chloride plus the methanol, and that is giving you the methyl ester, which is as follows. It can also be a carboxylate reacting via the SN2 pathway with a methyl iodide to give you the methyl ester. Or it can be a treatment of a carboxylic acid reacting with diazomethane, giving you the methyl ester. Now, how to deprotect these esters? Well, for that we will say it is basically base hydrolysis, also known as saponification, that is the soap forming reaction, okay, under basic conditions, which will lead to give you the carboxylic acid salts of sodium or potassium, which can be further treated with the acidified water to regenerate our desired acid. Now, if you want to protect the ester from base hydrolysis, but these, okay, suppose we have an ester in which we have a bulky, instead of a methyl, we have a bulky tertiary butyl group, okay. Say suppose T-butyl esters, okay, something of this nature. Now out here, these will be very stable to base. So if you use base, we will say no reaction, okay. But if we were to use acid such as trifluoroacetic acid, okay, this can be easily removed and regenerate the corresponding acid. So one has to keep in mind that whenever tertiary butyl esters are given, they are stable towards base. but unstable towards acid. Okay, whereas methyl esters can be cleaved by both the pathways. So let us use the line diagram to represent the strategy that we have discussed. Suppose this is your carboxylic acid, you have a Rx and a base. So it is basically your carboxylate that is reacting and leading to the formation of the MECOOR, where if R is CH3, then we are having a methyl ester. If your R is CH2PH, which can be removed, again we have discussed this before, by a catalytic hydrogenation, that is using PD and H2. So one can remove this. And if you want to produce a tertiary butyl ester, then we will use basically out here the isobutylene in presence of catalytic amount of acid, and that will give you the bulky esters that we desire. And the depreciation techniques have been already discussed in this lecture. Keep visiting Saravsar classes, and thanks for listening. Have a great day. We will be taking up deprotection and protection of amines in the next lecture. Thanks.